So in this question, kinetic energy of a particle is E. So kinetic energy is given as E, and its de Broglie wavelength is lambda. So there is a particle whose de Broglie wavelength is lambda, and its kinetic energy is given as E. On increasing its kinetic energy by delta E, its new de Broglie wavelength becomes lambda by 2. Then delta E is. So we have to find the change in kinetic energy we made, due to which the de Broglie wavelength becomes lambda by 2. So let's solve this question. So as you all know, lambda is equal to h by mv, means h by p. So where h is a Planck's constant and p is momentum. So we can replace this mv by this under root 2m ke. We can replace it. So so if you see this, it is kinetic energy. It is inversely proportional. Lambda is inversely proportional to under root of kinetic energy. So now let's see. So lambda upon lambda by 2 is equal to under root ke final by ke initial. So it becomes 4 ke initial is equal to ke final. So if you calculate delta E is equal to ke final minus ke initial, it will become 4 ke initial minus ke initial. So it will become 3 times E. So if you reduce the de Broglie wavelength from lambda to lambda by 2, the energy will change from E to 3E. So our answer will be 3E.